All right, so we're doing intro to testing, and just so you're aware, this is very introductory, right? So like, whenever you're talking about an intro to something, you can either try to go like really deep in one small area, or you can go really wide and just kind of cover high overview. And that's kind of where I wanted to go. Part of it is that I want to give you an idea of the way that I think about testing, because all of these tools, there's so much information out there about how to test well, and about how to use all these tools. And so I kind of want to give this high-level overview of how I think about testing, hoping that that'll give you something to think about whenever you're looking at some of the more deep patterns. So just to start, my name is Scott Maslar. I run a company, a consultancy called Maslar Industries. And if you were ever wondering about a proof for the fact that naming is hard, start a company and try to name it. It is the worst. I don't like that name at all, but that's what it is. Some other places I've worked, here locally up in Edmond, at Avtech was the first place I got a job. Then I went to FishMe, and then Vector Solutions, and then TeamSnap. I've been doing this like 7-8 years now, all Rails the entire time, and I absolutely love it. I'm very happy that worked out as it did. Okay, so intro to Rails testing. Let's start by just kind of talking about what are we trying to accomplish whenever we're talking about testing. There's this quote that I absolutely love. It kind of blew my mind whenever I heard it the first time, because I thought that testing was all about making sure that we don't have any bugs. But there's a guy that's really smart, much, much smarter than I am. And what he kind of realized and what he put into this like really small form that I love is testing shows the presence, not the absence of bugs. And here's the thing about testing. Unless you have an infinite amount of time and an infinite amount of money, and even then, I'm not sure that it's like mathematically possible, but you're never going to be able to get rid of every single bug. There's always going to be some kind of functionality that you just don't expect. And so testing is really all about trying to increase our confidence that the software that we've written is doing what we think it should be doing. And there's really 3 pieces to this confidence puzzle. It's doing what we want it to do now. So it's doing what we think that we wrote the code to do. I can't tell you how many times I've written a test for some code that I've written or for some code that somebody else has written and realized that the code is not doing at all what I thought it was doing, something entirely different. And so testing can very often kind of reveal our assumptions that we've made about what we think that this software is doing, and can help us parse through what's actually happening. The other piece that I really like is that it's easier to understand later. I am always so incredibly grateful whenever I come into a code base that has a bunch of tests, because I can look through those and kind of begin to understand what assumptions someone else had whenever they were writing this code. My favorite thing is to break people's tests so that I can kind of get an idea of whether the functionality is actually working the way that the tests are telling me it's working. Because this is one of the things that we have to realize about tests. Tests are code which don't have any test coverage, right? So the way that I use tests is always I want them to be as simple as possible, nothing fancy. I try to avoid like never any kind of recursion. I almost try to avoid like drying anything. I want my tests to be very verbose because I don't want any magic there, because I know that code is code that doesn't have any kind of testing. The last thing that's nice about tests is it increases our confidence that we'll be able to change or refactor this code later. One thing I didn't put in here is that it also increases our confidence that we can delete code, right? It gives us this kind of a backstop behind us to let us know that there's some kind of expectations are already being pushed against this code, so we have a better expectation as to what will happen if we get rid of it. Here's the thing. Tests cost something. They cost the time that it takes for them to run. So if your tests are very slow, the likelihood that you'll write new tests is lower. And they also take time to write. So we have to like measure this cost. We have to, there's always economics to anything that we're building. And so we have to measure this cost against whatever benefit that we're getting from our tests. As long as our tests are continuing to increase our confidence, then we can start to see the value and we can start to understand why we're spending this money. Whenever our tests are super fragile or are just not increasing our confidence, then it starts to get harder to really support this cost. I have in the references at the very end, there's an unbelievably good talk by Sandy Metz that I highly recommend everybody watch, that really digs into this idea further and kind of gives you a better idea of how to keep your tests from being too fragile, so they continue to be increasing your confidence and worth it. All right, so just going to give you an overview of the tools that I use. To be clear, there are tons of tools. Rails comes with Minitest. I like RSpec, but that's just because that's what I've always used. I like FactoryBot, also just because that's what I've always used. There are fixtures, there's other tools like FactoryBot that will give you the same functionality. Use whatever you and your team enjoy, use whatever works for you. This has worked well for me. Before we go too much further, I'm going to give you just a little bit of an idea of what FactoryBot will give us. FactoryBot is a tool for really allowing us to create test data that we'll use in our tests. So if you look at this top part, this is what you would find in one of the factory files. And it's really just defining, so you can see like factory user, so we're going to be creating a user object. And then there's 3 different attributes on that user record. And right here, they're each in like a block kind of format. That's going to be whatever is going to be set for each of those attributes. There's tons of functionality to make this much more interesting. You can add sequences so that you don't have a repeating email. You can have new emails. You can use something like Faker to just generate made-up names, which is always fun. But this is just the base functionality that FactoryBot's going to give us. And then in our tests, the way that we actually use this is you'll see build. So if you pass build a symbol, it will create basically, like you can imagine if your active record, it'd be like user.new, right? So it's not going to persist that record. Create, we'll actually call create on whatever it is that it's creating. And then down at the bottom, you can see this just returns a hash of the attributes for user. So it's basically just an easier way to get at that set of attributes that you've set up. So these are handy ways to just be able to deal with the data that you're going to be creating in your tests. Okay, so whenever we're talking about testing, there's kind of 3 different levels. You can kind of think about it as a spectrum, right? So there's unit tests on one side, and then there's integration specs on the other side, and then there's like some of these specs that kind of fall in between, but it's really a spectrum, and there's lots of different names for those middle tests, but I just call them a hybrid. They take a little bit of each side. So with the unit test, we're testing an individual component in isolation. So this is the situation where you can think about like model tests, right? Or a great example. It's one thing that we're testing. There's probably not any other kind of dependencies or anything like that. Hybrids are where we're testing basically a subsystem, right? So it's like a small number of components that are all working together to accomplish some goal, but it's not our entire app. So a good example of that would be like a controller spec. Integration specs are like the highest level where there's the most going on, there's most dependencies, there's the most stuff that you have to set up. And this is usually where you're thinking about, as a user, what's their experience going to be? So, you know, if you're talking about Rails, then you're probably talking about like web functionality. So the user tries to sign up for something. What's that experience like? And here's the thing about these tests, right, is that there's trade-offs. So unit tests are absurdly fast, especially if you're using build instead of create, so you're not actually persisting things to the database. These tests can be unbelievably fast. You can write a lot of them, and it doesn't hurt your performance. Hybrid tests are decent, and it kind of depends upon how you write them. You can definitely move them much closer to the unit side of the spectrum. Sometimes they can be a little bit integration-y, and that's why, like, they're in the middle. It's hard to really pin them down, but they're faster than integration. Integration specs are super slow, because you can imagine, like, you're pulling something up in a browser, you're having to click on things, you're having to move through the pages. That's just always going to be slower. There's lots of tools out there to try to improve the speed, but no matter what, it's going to be slower than these other two situations. Okay, so let's look at some unit specs. Specs, tests. If you use our spec, everything is called spec for some reason. If you use Minitest, everything's called test. These words are interchangeable. So like I said, with unit specs, we're talking about models, we're talking about testing views, we're talking about testing policies, anything where it's one component more or less in isolation. And here's our goal whenever we're writing a unit spec. We want to make assertions based upon the incoming messages, and then we want to either check the response from the message that's being sent, or we want to check the object state. And it kind of depends upon whether we're talking about a command or a query is going to determine which one we want to test. And this is where I highly recommend you go listen to Sandy Metz talk later today, later this week, whenever, because she really digs into this subject. It's at the end. It's on the reference slide. Absolutely, I put it up there because I want people to be able to go search it. Okay, so here's a simple object. It's a character class. We have a name. We have a level that they start at. If you look on line 9, there's that level up method, which will change the internal state of this object. And then we have this current level, which is really just a reader, right? So we can see like where our character is. So we're going to write some specs for this. So this is what our spec file could look like. It's maybe just a partial one. So you can see at the top, you can see that let character build character. Let is a functionality of our spec. It's super handy and I love it. Some people hate it, this kind of personal taste thing. But let, anytime you see let, it's basically going to set a variable inside the context of this spec. And then build character is what we saw earlier with FactoryBot, right? That's the functionality. So basically what's happening in that little line is we're building a character record with whatever attributes are set inside of that factory file, and then we're assigning it to the character variable. So then we'll be able to reuse that character throughout this test. And what's really nice about it is that with our spec, inside of these describe blocks, so like you can see each one of these is really their own context. And so anything that gets changed inside of that describe block will get reset for the next describe block if it's inside of that let. So basically for each one of these tests that we're running, that character will always be brand new. So we can always expect that that character variable will have its state reset and everything will function like it's the only test we're running. So here we've got a test for that current level. This is the situation where we really just want to find out like what the level of the character is right now. And so we're just have a little it block that says it returns the character's current level. So that's kind of telling us what we expect that this method will do. And then we have this line of code on line 8 where we expect that the character's current level will be equal to 1. And the thing I love about our spec, and Minitest does it similar, and you can read it and everything, but the thing I really like about our spec is that it lets me write code the way that I think. And so this just reads really well to me. I just expect that the current level method is going to be equal to 1. And as long as that's true, then this test will pass. So that's the situation where we're testing the state of the object. This next situation is where we have to ask something about the character. So we're testing the level up. We know that level up method is going to increase the character state by 1, based upon looking at the code that we had. So we got to grab the level that it was at before we called this method, right? And one of the things that I really like whenever I'm writing tests is I like to break up the spec as a whole into 3 stages, right? So there's this first stage, which is where we're doing the previous level, which is really where I'm capturing what I expect of the environment to be in before I do anything. And then there's the middle step, which is where I call character.levelUp, and that's where I'm doing some action that I expect will create some kind of a result. And then the last step is to test that that action actually created whatever result it was, right? And so I use space to kind of, visually display what's happening. So here's what I expect will start. Here's where I'm doing something that I expect will change my world. And then at the bottom is I'm asking, did it have the intended effect? Did it do the thing that I thought that it was going to do? So that's what a unit spec is like, right? And these are really simple, right? Like there's not a whole lot going on here. There's no magic. Everything that you need to know is really right inside that block. And that's the reason that they're so fast, right? That's the reason that you can just churn through a bunch of these. So hybrid specs, these are the situations where we're talking about a controller, or maybe we're talking about a service, like we learned about it at the last meetup. These are really the situations where we're testing a subsystem. So we're probably going to see a handful of objects. So instead of it being one component, we're probably going to see a few different components. And so there's going to be a lot more state, more than likely, that you're going to have to set up before you can run the test. And setting up state always means time. So the less state that you have, the less things that you have to set up, the faster it's going to run. The thing that you'll notice about the goal here is that the goal is almost identical to the unit goal, right? We're going to make an assertion based upon an incoming message, and then we're going to check the response, or we're going to check the object state. So we're going to take just like a straightforward scaffold controller from Rails and just did users scaffold. And we're going to look at the index and the show actions. So you can see, like, you can imagine, we're just grabbing all the users. We're going to be returning that to display. In the case of the user show, we're grabbing a specific user based upon the parameter that's been sent, the ID parameter, and we're going to be returning that one thing. So that's all that's happening here. But you can see, like, our tests already clearly have more going on. And this is a very simple example, right, of a controller spec. But we've got to create a new user based upon some valid attributes in this first situation. We've got to go and get the index. So that get is going to be given to us by our spec. It's basically makes it easier to make a get request. We've got to pass it some set of params. We probably have a session, right? Like, most applications have some way that you have to log in to the application, so we have to set up whatever that looks like. And then we're going to be checking on this response and making sure that it's successful. So this is a pretty simple situation, but you can see, like, there's already a lot of other pieces in this puzzle that have to be set up. There's all this other state that has to be handled. And so when we look at the show situation, right, we're doing the exact same thing. We're making sure that it's a successful response, and we have all of this other state. So we have to send the params. We got to make sure that the ID that we're sending is the ID for the user that we have. We have to make sure that we have a valid session. And then finally, we're going to check that this response is successful. So with any of these kind of hybrid specs, you really have to think about, like, whether this functionality is already being handled by one of the objects inside. So, like, here, we're not going to check whether the user's email is valid, or whether there's some part to that user that is correct. We really want to test only the controller. We want to make sure that whatever the controller is responsible for is actually what we're getting back. And so there's the thing I wanted you to see is that there's a lot more context that has to be set up in this kind of a spec, and that's the reason that it's going to take more time than you would see with a unit spec. But the goal that we're trying to accomplish is going to be very similar, and the way that we're going to test it is going to be very similar. Okay, so this is the final situation, right? And these are integration specs. And I don't know if you noticed, but there was like a rocket for unit specs. There's like a SUV for hybrid specs. And then we have this guy for integration specs, because the thing that you have to know is that integration specs are slow. They're so slow. And so the way that I think about integration specs is I want to use these for what Netflix calls the play button situation, right? These are the kinds of situations where if this part of my application doesn't work, then the value of my application is gone, right? Like, think about Netflix. If you're searching for movies and that doesn't work, I mean, that's a pain, right? But I'm probably not gonna get off Netflix. I can still see like whatever the main stuff is. But if I am clicking on a movie and I wanna watch it and I click play and that doesn't work, I'm leaving Netflix, right? So that's the kind of functionality that is gonna need an integration spec. Those are the kind of situations that you wanna think about, because these do cost more. And so you want to use them more strategically. You want to really use these to kind of test the areas where there's the highest value, there's the most importance for your customer, and it's worth the overhead of carrying this kind of a spec. So there's one additional tool that I have to mention in this kind of situation, and it's Capybara. Capybara handles all of the stuff about pulling up a browser window or faking a browser window and doing all of the DOM manipulation to make it easy to write these kind of tests. So it's a tool that's super helpful whenever you're writing integration specs, but it doesn't really come in on any of the other kind of specs. So the situation that we're trying to test here is going to be like a specific app feature, right? So it's a larger set of functionality that a user is going to experience. And we're going to be testing the app from the user's perspective. So you always want to be thinking about, as some kind of a user, what is my experience going to be? And maybe you have a situation where you're an administrator, and an administrator's experience is different than a regular user or whatever. You want to be thinking about it from the perspective of a user. And the way that we test this is going to be slightly different than the other two situations. So we're going to take an action as a user, and we're going to check the result via the application interface. Right, so this is where it's important. With an integration spec, one of the things that you can do is you could take some kind of an action as a user, and then you could try to test it by checking the database, right? Which your user can't check the database, right? So in these kind of situations, we don't want to take an action that is something the user can't do. And the reason for that is that the implementation details, like the fact that we're saving it to a database, could change, right? So we could expect that in the future, the same functionality is going to be stored in Redis, or the same functionality is going to be stored, on the browser, or there's all these different ways that we could store that information. And so we never want to rely on the implementation details in these situations that we know as developers. We want to instead use the application itself to verify whatever functionality it is, because that's what the user's experience is, right? So we want to make sure that a user takes an action, their experience is somehow communicated to them in the application. If you can't test it in the application, then maybe what you really have is one of those hybrid situations, and you shouldn't be testing it at the user level. You should take a step back and test some subsystem to get the same information. All right, so let's take a look at what one of these specs could look like. All right, so we have this feature. A visitor signs up. This is a pretty standard kind of situation that you would have in most SaaS businesses. So the visitor signs up with a valid email and password, and then these are the things that we have to do. And so Capybara is going to give us all of these different methods, like visit and fill in and click button, and you can kind of already hear in those words what's happening. We're visiting a web page, and that's the path that we have, the sign up path, and then we're filling in. So there's Capybara makes it really easy to find different fields on a web page and then put some kind of information in there. So we're going to fill in the email with our example. We're going to fill in the password with password, because what else would it be? And then we're going to click the button sign up. And then you can notice, on that expect line, we're going to expect the page that we're on to have the content sign out. So what we think happened, if this successfully happened, is that we can imagine the page would update. You'd click sign up, or you'd click that sign up button. The page would update, and now you would see the word sign out because you're signed in, right? So we would expect that that's changed, and we're using the information on the page to validate that whatever it was that we expected actually occurred. A different way that we could have done this is that we could click sign up, and then we could go to the database and make sure that there's actually a person that has that email address. But that wouldn't be respecting that boundary, right? We wouldn't be respecting the fact that the user's experience has to be everything that gives us this information. And so we're just going to check the page. We have the second situation where they're signing up with an invalid email, right? So we're going to not allow them to do that. Everything else is the same. They click the sign up button, and now we're going to expect the page to have the content signed in, right? And so we would expect that they didn't get signed in. They don't have the option to sign out because they're not actually signed in yet. And maybe instead of checking for the fact that they still need to sign in, maybe we could check for an error message or some other kind of user experience that they had. But the thing that we're really sticking to here is that we're going to make sure that we're only checking whatever that surface is, right? We're only going to check whatever the user would actually have access to. We're not going to skip down to the database or anything like that. So with this kind of a situation, like you can see that there's a lot more that's going to be invoked behind the scenes whenever you visit that sign-up path. I mean, you're going to be hitting controllers, you're going to be hitting views, you're probably going to be hitting active record in most situations. And then whenever you actually click fill in and you click that sign-up button, you're going to be hitting another controller, right? You're going to be hitting more views. You're going to be potentially creating a user via active record. And so all of those different actions that are happening behind the scenes are that's where all of the cost of this test is going to be. There's all this state, there's all this activity, and that's why these tests take so much longer to run, which is fine. It's totally fine as long as we're using these tests in the places where we actually care about. It's really, one of the things that's interesting to me is always whenever I come onto a project where they have like really only integration specs, there's just some upper limit where people stop writing them and you don't see any more tests after that. I've never come onto a project that has only unit tests and see like the group stop writing them. You might stop writing them if they're written in a really fragile way to where they break all the time whenever you try to make any kind of a change. But this is much more the situation where people will stop writing because the test just takes so long to run. They'll take forever. Okay, so that kind of ends my talk. Here's the things that you should totally take out your phone and take a picture of or look them up online. If you just type in the title, so like the magic tricks of testing or the Rails test types in the testing pyramid, if it's not your very first search result, you might add Rails or something, but it should be your first search result. If you add the rest of the information, then you'll definitely find it. These two things are unbelievably helpful, especially the magic tricks of testing. Highly recommend it. Honestly, anything that you can watch or read from Sandy Metz is going to immediately improve everything that you do with Ruby or Rails. So I can't recommend her enough. Are there any questions? What we got?
Someone on Twitch is asking, will you go back to the slide before the turtle?
Slide before the turtle. Yes.
He's asking, is there a reason that you are doing user create versus using let in the factory?
Yes, I will repeat the question. So the question was, is there a reason we're using user create instead of let and the factory? Yes, the only reason is struggling to fit it all on the page so that you could see everything. So yeah, that's the only reason. No, if I were writing this spec not for a presentation, then I would be totally using let and moving that up above. Because you can see like in both of those situations, you're doing the same thing, right? Like on line 46 and 54. And so no, there's absolutely no reason. I really just wanted to like have everything together so that we could really see all the state that has to be set up. That's an excellent question. Good eye. What do you got?
So how do you think about TDD or PDD? What do you think about that in your development process workflow?
Yeah, so the question is, how do I do TDD or VDD, and what do I think about that? I love it.
Maybe define those.
Yeah, that's great. So TDD is test-driven development. BDD is behavior-driven development. And the differences between those two are subtle enough that my small brain cannot fathom what they are. So basically, whenever you're talking about TDD, the idea is this red-green refactor. And so it's a cycle to writing tests. And the expectation is that you'll write a test first for whatever functionality you think that you want to have. You'll see that test fail, hence the red. And then you'll write the smallest amount of functionality that you need to write to get that test to pass, hence green. And then once you have that test passing, you can start to think about how could I change this so that it would better fit whatever, the way that I want this to be designed. I love it. I use it. It kind of like I am not a perfect TDD. I'm sure that there are perfect TDD people. I feel like in my experience, the way that I work, and this is probably just a lack of experience with doing test-driven development, is that in situations where I really know how I want it to work and kind of can see what the end would be, I'm much more comfortable writing my test first, and I'm much more comfortable working towards it that way. The place where I struggle personally is that if I don't have a great vision for where I'm headed, then it's a lot harder for me to figure out like what kind of tests should I actually be writing. The thing I really like about test-driven development, though, is that whenever you're writing tests for code that you will be writing, it forces you to keep things simple. Because writing tests for complex code is a nightmare. And with all of these things, all testing and writing good modular simple code, all of it is about increasing our confidence that we know that our code is doing whatever it is that we expect that it's doing, right? Like that's the peak thing, right? For writing code, all of it is for the humans that are going to be looking at it, right? The computer doesn't care. You could just do like the old C kind of thing, and everything could be a single letter variable name, and that's fine. The computer doesn't care at all. All of it is writing for us. And so anything that you can do to make things simple, to make things less complex, it's just easier to hold it all in your head. And writing tests first so often leads me in that direction of, because it's hard to write tests for complex things, it makes me write simpler code. So, yeah, good question. Any more questions? What you got?
Do you ever find yourself in a situation where you would write the integration test, but they feel like it's good enough, and then you'll skip the unit test and skip any other lower level test?
I have a bias against integration specs, and mostly just because I personally don't like writing them. I feel like they're the hardest tests for me to write well. And so if I'm going to start testing, it's always going to be on the unit side of the tests. And then like the more important that I feel like whatever feature it is that I'm working on, the more likely it is that I'll end up writing an integration spec for it. The other situation that I'll run into is like if there's something that I really thought I knew how it was working, and then a customer has a bad experience, or there's some kind of bug that comes up where it's obvious that like an integration spec would have helped me understand like what was happening, or it would keep it from happening in the future. That's the situation where I'll write an integration spec. So for me personally, I don't end up in that situation only because of my bias, right? Like I will always start with the unit specs, and you got to force me to write an integration spec. But I think that works the other way too, right? So if you primarily write integration specs, I would suspect strongly that you would find situations where a unit spec is going to cover some hidden piece of functionality that isn't really customer centric. Maybe it's a job that runs in the background, and so testing it via an integration spec would be impossible or really hard or really time consuming. And so I would suspect that there are probably going to be situations where you'll find that a unit spec is going to serve you much better. And so it would just kind of drive you in that direction. I wouldn't be surprised, but that's not my experience because like I said, For better or worse, integration specs are my worst nightmare. That is by no means a slight towards integration specs. They are an excellent tool. This is much more a slight towards my own capability than anything else, so, for what it's worth. Any other question? Yeah?
Do you have any thoughts on the relative sizes of test base versus the code base?
Oh, yeah. That's an excellent question. So the question was, do I have any thoughts on the relative size of a code base versus the test base? So like code coverage, right, is another way of talking about that. I think, in my experience, once you get past 90% code coverage, I feel like you're kind of lying to yourself, right? Like at that point, you're just not, the likelihood that those tests are actually increasing your confidence versus the cost of writing them, like you get pretty low. I think that decent code coverage, in my experience, like 70% is about the low end. Between 80 and 90, you're probably in a pretty good spot. And that's totally my experience on, the 6 places that I've worked. So, take that with a grain of salt. But I would say between 80 and 90%, you're probably pretty good. I think that the important thing to remember is, if you're getting to a space where you hate writing tests, like where they're too slow or whatever, you should never be afraid to delete any kind of code, right? And that's always our goal, is just to increase our confidence that we can make the changes that we need to make to meet the business needs that we have. And that's the reality of writing any kind of software, is that we have all of these constraints on what we're able to do. We have constraints on time, we have constraints on money, and we have constraints, honestly, on what our product should be doing for it to actually be of value to the customer. We end up, as with any industry, we end up with a lot of fake constraints on ourselves too, like, things that don't actually improve the software. But there are some real constraints to how we have to write things. And so, in my experience, 80 to 90% is great. Below 70%, your confidence is probably going to be lower than you would like it to be. And anything over 90, you're hitting diminishing returns. I don't know that you're going to get your value. Any other thoughts on that one? Any other experiences? Any other questions? These are good questions. Any more Twitch questions? Okay, sweet. All right, well, thanks, y'all. Oh, and I'll put this back. Oop, too far. Just in case anyone didn't get an opportunity to grab that information. Highly recommended. All right, thanks, y'all.